Let's count how many monotonous positive integers we have. So I'm going to underline some keywords. It has to be a positive integer, and what monotonous means is all its digits are either strictly increasing or strictly decreasing. And another keyword is strictly. And so first, let's just get some like conditions. What does a monotonous number even mean? Well, it means if we plot like the digit position versus the like actual like digit, so this is like position versus the digit, it either has to be strictly increasing or it could either be strictly decreasing. We can't have stuff like this or stuff like this where it's increasing, then decreasing, decreasing, then increasing. You can look at that with this number right here for 2, 3, 5, 7, 8. Well, 2, 3, 5 is increasing, and then 7, or 2, 3, 5, 7, 8, they're all increasing. So this is actually a working example. But the 7, 4, 3, 4, for example, that doesn't work because we're going to have like a 7 and then decreases to 4 and then it decreases to 3 and then it increases to 4 again. And so it's decreasing and increasing. That is not strictly decreasing or strictly increasing. So we can't have that. And so it just has to be straight up or straight down, just a straight line. Now, another condition we can have is that, well, it has to be strictly increasing, so there can't be any repeat digits. We can't have a repeat of the digit 8, we can't have a repeat of the digit 4, we can't have a repeat of the digit 5, and I'll tell you why. Suppose that we do have a repeat of the digit, so suppose it's going to be like something, and say we repeat some random digit like 3, 3, and then so on and so forth. We can't actually have this because if we're looking at the graph of this thing, like this graph right here, our digit diagram is going to look like this. Say it's increasing, and then it's going to be flat, and then it's going to be increasing again. Or if it's a decreasing number, it's going to be decreasing, flat, decreasing again. And the problem is that this is flat now. And we can't have flats because it has to be strictly increasing or strictly decreasing. It's like this part is flat, it's not increasing. Same thing here, it's flat, not decreasing, it's not strictly. And so we can't actually have this, so we can't have repeat digits. So now let's actually move on. Let's make some progress. There's two sorts of cases here. Case 1 is increasing. Case 2 is decreasing. And now let's just count these. So let's look at case 1 first. And for the case 1, I'm only going to consider digits 1, 2, 3, and so on all the way until 9. I'm not going to consider 0. And the reason why is for an increasing number, 0 is always going to be the first digit, no matter the increasing sequence. If there's a 0, it's always going to be the first digit. So we have like 2, 3, 9. That's increasing. But if we have a 0, then 0 is going to go in front. And 0, 2, 3, 9 is the same thing as 2, 3, 9. We can't really like append a 0 to the front. That doesn't change the number. So I'm just not even going to include him because he's always going to be in the front and doing something like redundant like this. So we have 9 digits. So now we want to find the number of ways we can take subsets of these 9 digits. We basically want to say we're going to include some of these numbers, we're not going to include some of the other numbers. So how many ways can we take subsets of this? And the formula for that is just 2 to the 9th. Because there's 9 digits, each one of these has 2 options. So 1 has 2 options. It can be included in the number we're going to create, or it can be not included. 2 has 2 options. It can be included or not included in the number we're going to create, and so on and so forth. So it's just 2 times 2 times 2 times 2 times 2, 9 times, which is 2 to the 9th. And so now we have 2 to the 9th different ways we can choose a subset. Now we're going to multiply by 1, because once we have a subset, there's only one way to make them in a strictly increasing order. So like once we have a subset of numbers, there's only like one way we can actually make them strictly increasing, because there's not going to be multiple ways where they're strictly increasing, because any like switch you make is going to like make it decreasing, if that makes sense. But there's only going to be one way. But now we're also going to subtract off 1. And the reason I'm going to subtract off 1 is because when we're taking subsets, the empty set is a subset of any set. That's equal to the empty set is a subset of any set. So technically the empty set could be a subset of this. And the empty set basically means that we've selected no numbers to create our number or digit with, or no digits to create our number with. And if we create no digits to create our number with, we're not really going to have a number, and that really doesn't make any sense. So we're going to subtract off 1 because we have no digits there. And now let's move on to case 2, decreasing, but this time we can include 0, so on and so forth until 9, because if it's decreasing, then we're going to have like 9, 3, 2, and then so on and so forth, and it's going to be 0 at the end. And 932 ... is not the same as 932 ... 0. These are two different numbers, so we're going to include the 0, and by the same process, we get 2 to the 10th times 1 minus 1. So now we just need to sum these. So we get 2 to the 10th plus 2 to the 9th minus 2. But notice we're not done yet. That's the trap of this problem. And the trap of this problem is that we double counted a certain type or certain class of numbers, and these are the 1-digit numbers. So if we've double counted in the first example, so case 1, we counted 1, 2, 3, 4, 5, 6, all the way up until 9. We counted these numbers as strictly increasing numbers. But in case 2, we also counted these same exact numbers, 4, 5, 6, 7, or 8, 9, We also counted these as strictly decreasing numbers, and also in number 2 we counted 0 as a strictly decreasing number. So these guys are getting double counted. And I only want to count it once. So I'm going to forget about the 0 for now. We'll just keep that in the back of my mind. We're counting the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 twice. And I only want to count it once because they're getting represented twice. I just need to count it once. So I'm going to subtract off a 9 from this. So that means we only counted these one time. But now we got to deal with the 0. And notice that we're asked for positive integers. 0 is not positive, so we also have to rule out this 0 guy, so minus 1. So the final equation is 2 to the 10th plus 2 to the 9th, and this all is going to sum to negative 12. So 2 to the 10th plus 2 to the 9th minus 12, which is 1024, plus 512 minus 12, and this simplifies very nicely. It's just 500. So the final answer is 1524. Let's see if that's an answer in the answer choices. And 1524 is answer B.